everyone, and welcome to the CS Club and SE Soc interview prep workshop. We have two fourth-year students, Kristy and Bimesh, who created amazing slides to help with tips and tricks for your upcoming interview season. There's also a Slido link that will be posted in chat and also at the bottom of the screen for you to go to and ask any questions that will be used later on in the Q&A period. And yeah, I'll pass it off to Kristy to take it away.
Thanks, Alex. Let's get started. So quick introduction from Bimesh and I. Hi, my name is Kristy. I'm in between my 3B and 4A terms of computer science. I'm currently on my last co-op. Some notable co-ops I've had in the past have been at Cockroach Labs, Google, and PayPal. And fun fact about me, I'm really good at flipping omelets. I've not dropped an omelet in a very long time.
Hey everyone, I'm Bimesh. I'm in 4A SE, and I worked at a bunch of interesting places. And something that's interesting about me is I enjoy really, really long bike rides. And once I biked from Waterloo back to the GTA, and that was fun.
All right, so first let's get into today's agenda. So a little bit of a preface for today's workshop. We are assuming that you, the viewers, have a basic understanding of common algorithm and data structure topics. We can't reteach all of CS 341 within 1 hour, but we can talk about the more applicable aspects of it to interviews and step away from the purely academic view of it. After every few topics, we're going to do a quick demo interview. And as I mentioned earlier, this workshop will focus on the strategies in these topics that are helpful for interviews. The academic side of it and theoretical side of it, there's plenty of resources online for you to study that we will have at the end of this workshop. So for the algorithms and data structures we're covering big O notation, arrays and strings, linked lists, stacks and queues, hash tables, trees and graphs, dynamic programming, and sorting and searching. And a little aside from all the LeetCode and technical internship, or the technical interviewing stuff, just a reminder that there's more to just LeetCode to getting a job. Remember to have very concise quality resume points. I suggest writing them when the work you've done is fresh in your mind. So if you just got off of co-op last term, make sure you really know what you did last term and can really speak to it. Speaking of which, you should be able to speak to the impact of your work, be product-minded, not just about the technical challenges you faced, and be specific about your contributions rather than just saying, I worked on a very large feature. Try to call out the specific things within that feature you worked on. Was it caching? Was it end-to-end tests? So on and so forth. That aside, let's jump right into the LeetCode stuff. So first up, really quick chat about big O notation. It's basically describing the speed or space resource relationship to the input size, where n is the input size. Some helpful ways to think about it when you're in the middle of a coding interview and someone's asking you after you've written up a beautiful solution, they ask you, what's the space complexity? What's the speed complexity on this? So what I find helpful is to look at the nested loops. For one loop, you have at least O of n for every nested loop inwards. You raise the exponent on it. So one loop is O of n. A double nested loop is n squared, and so on and so forth. And for log n, it often occurs alongside divide and conquer type problems. So for example, binary search or quicksort, which is more n log n. But more on that later. Arrays and strings. I really hope you know what arrays and strings are. But in particular, in interviews, sorting and searching often come up in these types of questions. They might be the centerpiece of an interview question. They might not be. So some helpful guides with arrays and strings. If you need to search the array, if it's already sorted, use something like binary search. You're only getting log n on speed complexity. If the array is not sorted, look towards something like hash tables or a kind of linear search, maybe bucket or count sort, to get at least linear time to search through your table. Sorry, not table, array. Or you can also do it yourself. More on that later as well. All right, speeding right through it. Linked lists. You know the drill. One node has a value, points to another node, has a value, points to another node, has value. Maybe it points to null, maybe it points to another node. Please remember the structure in your language of choice, and please remember how to type it out. It's gonna come up, and it's gonna be really awkward if you're not used to doing a lot of object-oriented stuff, since you're so focused on the algorithms and data structures that you stumble on implementing a node in your language of choice. So keep that in mind. All right, so we're going to jump right into our first demo problem. So given a root, return the middle of a linked list. And we're going to switch over to some coder pad. All right, Bimesh, take it away.
Okay, awesome. Okay, so how is this root going to be given to me?
Yeah, you can assume you're getting a node object.
A node object. Is this defined anywhere?
No, you can set your assumptions about the object.
Okay, cool. So I'll define it then. You know what? Let's do that first so we know what we're talking about. So we have a node class. So this is a node inside a linked list, and it points to a next node, and it contains some sort of data. Is that correct?
Yep, that's correct.
Anything else?
No, that sounds about right.
Okay, sure. Let me write that part out then. Okay, so we have a node, and we're going to have the init. Inside here, we will take in the data. Okay. I'll assume that we're not going to have the next node. We could add that into the constructor later if need be. And we can set our next to like none to represent like no node to begin with. Okay, so this is our node structure. So I'm given one of these. Okay, and I want to return the middle of a linked list. Okay, middle of a linked list. So do I return the node at the middle?
Yep, that's correct,
Okay.
the node object.
Okay, so the node, not the value. Okay. Okay. Okay, and I see you say middle. So what happens if there are an even number of nodes? Like which one is the middle?
Yeah, that's a great question. In that situation, either qualifying middle node is acceptable.
Even case, either middle node works. Okay, that's good. Okay, so a solution that comes to mind right now is imagine we could start at the beginning, the first node, and we can go all the way along to the end, counting how many nodes there are. And then after we count, then we can do a second pass where we go to like halfway along. So say we count that there are 5 nodes, then we can go to the second node and return that one in the second pass.
Sounds like a plan.
Yeah. Okay. Thank you. So could there be any like how's the input format? Could I assume that there are like no cycles, nodes are like the input is not null, like
Yeah, you can assume you're getting no cycles. The input might be null though.
okay, cool. Okay. Okay, so with that solution in mind, do you think I could start coding?
Yeah, absolutely.
Okay, let's go for it. So call this like find middle. It'll take in a node. I'll call it head. Okay, and I'm going to first do the part where I count number of nodes, and then I'm going to return the middle. So let's first do this part. Okay, so you said that head might be null, so I'll deal with that case first. So in that case, should I just return none?
Yeah, that sounds about right.
Good. Okay. Okay, so now let's count the number of nodes. So let it count here, or whoops, mixing up languages here. Okay, count. Okay, and now we're going to loop through. So file our, let's like create a new node here. The reason I'm doing this is because we need to save the head so we can go iterate starting from the beginning for the second time. So I'll just create a new node here. Okay, so while this isn't none, we're just going to get the next one. So node equals node dot next. And we are going to increment our count. Okay, so to make sure I did this correctly, if there's just one element, we'll go into this loop once. Node.next will be none, then count will be set to 1, and then node will be none. So we'll go out of the loop without incrementing count again. So that looks about right. Okay, so at this point, we know how many nodes are in our list. So then now we have to do is we have to find the middle element and return it. So let's figure out what the middle. Let's just get the middle value there. Okay, and then we're going to find that node. So just say middle. We're going to set node equal to head again, and we're going to increment that many times. So node equals node dot next. Okay, and finally return node. So I want to make sure that I don't have an off by one error or something here. So say we have a case where there are 5 elements. So say we have a case where, you know what, let's just say we have, 5 elements. Okay, 1, 2, 3, 4, 5. So in this case, we'll have count equal to 5. Okay, so count equals 5. And then we're going to set middle in that case equal to 3. So, equal to 2. And then we're going to set node equal to head, and we're going to move forward 2 times. So node's going to start at 1, and then it's going to go to 2 and to 3. Okay, in the odd case, that seems correct. We'll get the correct element. Okay, so what about in the even case? So in the even case, if we have count is equal to 4, then middle will be equal to 2. And if we go 2 times, starting from here, we'll end up at 3. And that will be like the right side. So I think that is also a valid answer according to the problem definition. Okay. Is there anything else on your mind? Anything you're seeing?
No, this is great. Let's talk about complexity for a second here. What do you think the speed complexity is?
Okay, sure. So we start at the head node, and then we go all the way to the end. So that first iteration will take O of n time, n being the number of nodes in the list. And then the second iteration, we again go like halfway to the list. So basically, we do 2 O of n passes to figure this out. So this time complexity is O of n.
Great. And the space complexity?
So we don't use any additional space here aside from these variables we save. So like these pointers we save and these integers. So it's like constant additional space, but I guess we have O of n input size.
Awesome. This is great. Thank you very much, Bimesh.
Okay, awesome.
Move back to the slides. So yeah, that was our problem. So what went well? Bimesh asked a lot of questions. He wrote down all of his assumptions. He asked about what to do in the even case for linked lists, what to do, like if there were any cycles. He wrote down the definition of the node. That won't always be necessary, but it's nice to know what we're working with. Yeah, he went with like the most intuitive solution first. We didn't dive into the other solution of only one pass, but it's good to get out what you know works first. So next subject is stacks and queues. So stacks and queues, hope you know these as well. First in, first out for stacks, and last in, first out for queues based on the different functions that are provided. Something that can be helpful for interviews is to be flexible with how you interpret a stack or queue. It might be very intuitive to think of a stack or queue as an array, but we might want to be flexible and think of stacks and queues as implemented through linked lists. Or not get too hung up on a specific implementation at all. So for the next problem for Bimesh, we're going to check for balanced brackets. So for example, this very messy set of brackets actually happens to be balanced, but this, however, is not balanced. So back to the coder pad.
Balanced brackets, interesting. So I see there's like a bunch of types of brackets here. Is there like a fixed set of brackets?
Yeah, that's a great question. We're just gonna go with 3 different kinds of brackets.
Okay.
So I can actually type them down here for you. So square brackets, curly brackets, and parentheses.
Cool. Okay. I see. So how is the input given to me?
Yeah, you can assume you're receiving a string.
A string. Okay. You know what? Let me write out the function definition here. So basically, we are trying to find balanced brackets, and we are given brackets, and this is like a string, and we want to return. What are we returning? Boolean?
Yeah, Boolean is good.
Okay. Good. Okay. So, let's see. Okay, so what does it mean for it to be balanced? Is it just that the number of closing and ending brackets match up, or are there more conditions?
No. So for example, in the second case, the number of closing and ending brackets do match up. However, the brackets kind of slice in between each other and are therefore not balanced.
Okay, that makes sense. Okay, what about this case? Like, what if we have a closing bracket and then an ending bracket? Like, is that balanced?
Yeah, great question. That is not a balanced bracket.
That's not balanced. Okay, so basically, we need to make sure. What do we need to make sure? We need to make sure that uh, the brackets are like closed in the right order, and you can only close brackets that have been opened. So
Correct.
if there's a, yeah, okay, good. Okay, so let's think here. Is there anything else? Okay, so this kind of leads me to a solution that makes me think about kind of like a stack where you have like brackets stacking up on top of each other, and then when you close it, you can only close the bracket that's at the very top of the stack. So I wonder if we could represent these brackets in sort of like a stack structure, and then when we find a closing bracket, we can check if the bracket at the top of the stack is the equivalent opening bracket for the closing bracket we just found.
Sounds like a great idea.
Okay. I guess if we do this, we need some way to map between closing brackets and opening brackets. So I'll probably create like a map to do that. Okay. I wonder if there are any edge cases here I need to think about. So will brackets always be, so you told me brackets will only be these three. So I could assume there aren't any other characters in here.
Yeah, you can assume that there's no like pointy brackets or any random characters like that.
Cool. Okay. And will brackets always be a string? Like will always be like non-null?
Yeah, always non-null.
Okay, awesome. Okay. Okay, so then I guess the algorithm that I had in mind was we loop through, so brackets, add opening brackets to stack, and whenever we find a closing bracket, we want to see if the equivalent opening bracket is at the top. Okay, so then that means the two ways that this could return false is if we ever find a closing bracket that doesn't match to the bracket at the top, or if by the time we get to the end, there are brackets that aren't closed. Are there any other ways that this could fail?
No, that sounds correct.
Okay, great. Okay, so basically fail if okay, and also yeah, the last one I said. So great. Okay, so do you think I could jump into coding here?
Absolutely.
Okay, awesome. Let's do it. Great. So we'll have a stack. So for a stack, since I want to be able to add and remove things at the end in constant time, I'll use a deck, which is like a linked list structure in Python. So I'll call this my stack, maybe call it a bracket stack or something. That's my stack. And now we are going to add brackets to it. So for we're going to add it to the stack. So we only want to add it to the stack if it's an opening bracket. So one way we can check if it's opening bracket is to see if it's not a closing bracket, because we know there are no other invalid things. And we'll have all the closing brackets in our map. So I might as well define that map right now. So I'm imagining having something like this, where we have map from closing to opening. And this guy will contain each possible like opening or each possible closing bracket and mapped to each its equivalent opening bracket. This guy, this one, and this guy maps to this one. Okay, I think I got that one right. Okay, great. So now to check if something is a is an opening bracket, all we have to do is see if it's not one of the keys inside here. So if bracket in not in closing, then we know it's an opening bracket because there aren't any invalid characters, and then we can add it to our stack. Great. Okay, so that's the case when we find something that is a opening bracket. Okay, so now let's deal with the case where we get a closing bracket. Okay, so what we want to do now is whenever we get a closing bracket, we want to see if it matches the bracket at the top. So one, like if the stack is empty, that means it's not going to match because there's no opening bracket. So we can deal with that case. So if this is empty, then we can just return false right away. False. Okay. And the other thing we want to check for is if it matches. So otherwise, if equals the equivalent opening bracket. So, bracket. Great. So this gets the closing bracket that's the equivalent of this one, and stack.pop removes the top bracket of my stack. So if it doesn't equal, then what we want to do is we'll return false. Okay. And if we go through all of the brackets and finally it's not empty, that means all the open brackets were closed. So here we can just return I guess just return like I could just return not stack, but to be clear, I'll say len of stack equals 0. So we want to make sure that it's like empty. So if it's empty, then it's good. Okay, and to be clear, another edge case I thought of. So if there are no brackets at all in the string, is that also valid?
That's a great question. Yeah, I think a string with no brackets is balanced.
Okay, good. So in that case, it would do nothing, and it will end up being true here. So I think that's good. Okay. For the sake of time, I'm not going to go into more examples. Or like run through examples, but I probably would in a real interview. But do you have any questions about this code? Anything that jumps out at you?
No, for the sake of time, we'll also skip over the time and space complexity.
Okay, great.
All right, back to the slides. Great job, Bimesh. Yeah, what went well, again, went through all the assumptions and everything, but also described what he was going to be doing before going into coding.
Okay, presentation time. So hash tables, they are an extremely useful data structure in interviews. They come up a lot, and the biggest reason for that is because they have constant time lookups and insertions. Some things you should know about them are like how they accomplish this like property and also how they work internally. For some context about how it works internally, for like say 99% of your interviews, you won't need to know how to build a hash table from scratch. However, knowing how hash tables and other common structures and algorithms we talk about in this presentation work on the inside will help provide you with intuition. So you can decide which structure or algorithm to use for a particular case, because usually it's not like very obvious, and understanding how they work will help you match it to kind of like more unique cases. Yeah, so that's why even if you won't need to actually like code out a hash table, understanding how they work on the inside could still be useful. Okay, oh, next slide. Okay, so a typical problem for hash tables to sum. Find two numbers in an array that sum up to a given integer n. Kristy.
All right. All right, find two numbers in an array that sum up to an integer n. So my initial impression of this question and my kind of gut reaction on how to solve this is for each element in the array, say starting at 1, look at all the other elements within the array and see if any of them could add up with 1 to equal n. Now, unfortunately, this is not a very fast algorithm. This would be n squared, as for each element, I would be iterating through the entire array. However, the nice aspect of it is that it doesn't use any extra space. Is there a particular trade-off for time and space that you're looking for?
Let's say we get the best possible time complexity.
All right. So with the interest of best possible time complexity, maybe I could use some kind of structure that takes up some space but helps do a lot faster lookup. Thankfully, something called a hash table exists. So I have an idea where I could first iterate through the array and save all its values to a hash table, and then iterate through the array once more. And for each element, if the respective correct item adding up to the correct sum exists in the table, then we would have a matching pair, and then we could return that. Now, one issue I could see with that is if, for example, our n is 3, if, for example, our n is 4, 2 might look at itself within the hash table, and then my algorithm might return both 2 and 2. Should I worry about this edge case?
You should.
All right. Okay, I'll keep that in mind. A way to keep that, the kind of like work around that, is to add a counter to my hash table to keep track of how many of each value exists. So, I didn't make any notes for that. That's my bad. So n squared solution for each item, look through array for there, and then my linear time build hash table of items. If there are multiple solutions, do you want me to return all of them or just the first solution?
Any of them, any solution works.
All right. All right. Then if that's all right with you, I'm going to jump right into coding it.
Sounds good.
So first I'm going to build up my map. All right, and here I want to count the number of times the actual item shows up in the array. So first I'm going to check if the item exists in the map yet. So if it doesn't exist, then make it exist. And otherwise, increment. All right, so that should count up the number of times each item occurs. So to help me deal with my edge case, I'm actually going to change the way I think about this. Yeah, so I actually want 3, 1 from here, not 2, 2. All right. that's my hash table. Next, I'm going to look through the array and try to find a correct pair, keeping in mind that I might be double counting things that are of the same value. So we're just going to run through this again. All right, so if, let's make a target for readability sake. So target's going to be n minus the array at I. So that's what we're looking for to be table. So the target is in the map, and actually I'll ignore the edge case just to simplify things for now. But basically, if the target is in the map, then return that lovely pair, which would be array at I and target. But of course, life is not that simple, so I'm gonna go for that edge case. So in the case that the item we are handling is half of n, because that's the only edge case we can really have here for two-sum regarding the double counting situation. So if the value is equal to half of n, then we need to make sure map at array value or at target, consider the same thing, is at least 2. So I'll actually just add this in here. Then, oops. Also do that. Okay. Okay, I got some weird things going on right now with my if statements, so I will just clear that up. All right, so if the target is in the map, first let's make sure that, if we're dealing with the potential double count case, then there's at least 2 of that item in there. Otherwise, we're not dealing with the double count case, so it's fine to return, and then continue looking. What should I be returning if there is no solution?
You could return, let's say -1, -1.
All right. And I think that's it for my first run through. Yeah. Making the map and then looking for the target.
Cool. So what would be the runtime, runtime and space complexity?
Yeah, so regarding runtime, first we do one pass over the array to build up the map. And then we do one pass over the array to find the solution. So runtime, it's 2 ON runs, which makes it linear time. So it's ON overall. In terms of space complexity, the amount of memory we're using is directly related to the size of the input, since or in worst case, directly related to the size of the input, since we're creating an entry in the hash map for each unique item in the array. So that would make the space at worst ON as well.
Okay, cool. That sounds good to me.
All right.
Okay, awesome. So I think what was really great there is Kristy provided the brute force idea first. This is especially useful if you need some time to think of the better solution or the faster solution, but either way, it's a good approach. Also, it's great how she considered trade-offs between space and time and asked me which one I prefer, because it's quite possible your interviewer might tell you, oh, prioritize space or something, and that you recognize this is great. Okay, so this is quite a content-dense slide. Trees, graphs, heaps, a bunch of stuff. Okay, so core trees like binary trees, binary search trees are quite common. There are lots of problems related to these on LeetCode and other sites. You should do some of these problems because they come up quite often in interviews. Some ways to traverse trees are listed there. There are heaps. Like heaps are very useful in like lots of cases. One particular case is keeping track of min and max values. For example, say you're traversing across a list and you want to keep track of the top 5 elements in the list. Using a heap will be potentially one of the fastest runtime ways of accomplishing that by like keeping the top 5 elements you've seen so far in the heap, for example. Okay, so when dealing with these structures, recursion or queues come in extremely handy. Like for lots of tree questions, for example, like recursion is typically a very easy way to wrap your head around the problem because you can deal with what you're doing at a single node instead of like thinking of the whole problem like as a whole. So yeah, depending on what you want to do, either recursion or queues are great. Okay, so on the right side of the slide, that's stuff talking about graphs in general. So BFS and DFS are two very common ways of traversing graphs, and I would suggest doing some problems where you use both of these like algorithms. And so next time you see a problem in an interview, you can be like, oh, like this sounds like the sort of thing that I could use DFS for. And probably in your interviews, you wouldn't use like some sort of vanilla DFS. You'd probably modify it a bit to match the problem. So doing some problems using the algorithms will help you be able to do those modifications. Okay, so here's another problem. So given the roots of two binary trees, P and Q, write a function to check if they are the same or not. And they're the same if they are structurally identical and all of their nodes have the same values.
Okay. All right. So the first thing that jumps out to me is the definition of being structurally identical. Can you elaborate a little bit on what structurally identical means?
Sure. Okay. So any node, its like left and right children should be the same in both trees. So yeah. So the structure, so if you like draw it out, it would look the exact same.
Got it. And okay, yeah, drawing it out is the same, and the nodes have the same value. And I'm assuming as well that we both want the structures to be identical, but also the nodes in the particular locations to have the same values, not just that there are similar values across the trees, but that like the location of the node is structurally correct and value-wise correct.
Yeah, that's exactly right.
Okay, great. I'll just note that down. All right. So to kind of like double check my understanding, and I'm just kind of thinking out loud here, given a node or like a node here, I'm going to say if the right side of its tree, given the same node from two trees, if the right sides are both structurally and value-wise correct, and the left sides are both value-wise and structurally correct, and the values at the nodes I'm looking at are value-wise correct, then everything up to that point is going to be a structurally identical and, it's going to be the same. So I'll write that down really quick.
That sounds right.
All right, then I feel pretty confident in this somewhat recursive definition, and I'm gonna jump right into programming it.
Sounds good.
Yeah, actually, before that, binary trees. So just for the interest of time, I'm not gonna implement the entire node, but my understanding is like each node is gonna have like a node dot left, node dot right, and a node dot like value.
That seems reasonable.
All right. So let's jump right into it. So I'm getting P and Q. And just to clarify, I want to return a Boolean, true being that they are the same and false being that they're not the same.
Mhm.
Okay, and could I potentially get null nodes at the start?
Nope, don't need to worry about that.
Okay, don't need to worry about that. Well, kind of going off this statement first, I'm gonna roughly work on like the last case of what my recursive function would be. So I want to make sure that the left and right sides are the same and that the current node values are the same. So same tree, I'm gonna pass down the same left and the same right. And that the current values are the same. So now, definitely plenty of edge cases to work with here. So I'm going to step back a bit and think about those. So first thing for sure is you get into a situation where like P is null, but Q isn't, or Q is null and P isn't. Or if you're at the very like leaf of a node, you might just accidentally get null, Q, and P. So I'm going to check on that case first. So if and nice to have, but this does start to cover the case where we're given P and Q as null, although that is not specified. Just a nice to have. Okay, now, other unfortunate cases, P is null, but Q isn't, and then vice versa. So in those cases, we're definitely not on the right track. Just to check it, and then grab this again. All right. So this leaves us with P and Q not being null, so they have to have a left and a right, and they have to have a value. So I think I've covered all the cases. I've covered if P and Q are both null, in which case they are technically the same tree, so true. I've covered the cases where P and Q, one is null, one is not, so therefore they're not structurally the same, and so return false. And that leaves us with checking if the left side of the tree, right side of the tree are the same, as well as if the values at the root are the same. And actually, to make things a little bit more efficient, I'm gonna check the value of the root first. That way I don't have to use up a whole recursive call if that fails. All right.
Cool. That looks good to me. So what are the runtimes and space complexities of this?
Yeah, space-wise, we're not storing anything here. We're just doing some a lot of recursive calls. Runtime-wise, it's bounded by the size of whichever tree is largest between Q and P. Actually, whichever tree is smallest between Q and P, since we'll probably end pretty early with these like unbalanced checks. But yeah, worst case scenario, size of Q or P.
Okay, cool. Okay, that's great. I think that's all the questions I have. Okay, so moving right along. Dynamic programming. This one always sounds fancy, but basically it's saving old values that you've computed. I'm assuming all of you have learned about DP in some initial CS class, but if you haven't, typically my way of approaching DP problems is I think of the non-DP approach first, like think just like either explain or think out how to do it. Afterwards, I could, or even like draw out the recursion graph. So then you kind of know the structure in your mind and you can explain that to the interviewer. And only after I figure out that non-DP approach, then I could figure out what the duplicate work is. So you can only use DP if there is duplicate work you do over and over again. So memoizing, or that's the fancy word for saving, work that you've already done will allow you to reduce your time complexity to whatever the size of your DP table is. I guess, multiplied by whatever it takes to compute each value. So a debate around DP always is like, should you build up or not build up your DP table from the beginning? I typically find like it's easier in your mind, like for you to think of like a not build up DP solution, because you can just have your brute force and then kind of like write out the equivalent of like a cache or something for like a given key and value, or like a given input into your function. If you save the work for that function, then you can use it as your DP table kind of. However, it's typically recommended that you build up a DP table from scratch, because if you build it up from scratch, you're not doing unnecessary recursive calls to structures that you don't necessarily need. So building up from scratch is generally more efficient, and you end up with like a much cleaner and simpler solution, even if it might be harder to figure it out intuitively. So yeah. Great. So this is a typical DP problem we talk about in class. So given like a number n, calculate the Fibonacci nth number. Fibonacci number. Yeah.
All right. So right off the bat, Fibonacci numbers kindly come with a nice little recursive statement on how to calculate them. So just to help me think through this problem, I'm going to code out the most naive solution to this, which is to directly implement that recursion. And luckily for me as well, the 0 case and 1 case are already defined. So and then otherwise, I'm going to do that recursive call. So I want the solution of the n minus 1 plus the solution of the n minus 2. Now, this is nice and clean, but this has also helped me realize just how many recursive calls we're going to be doing. There's going to be a lot of overlap as well. So for example, if my n is 10, I'm going to be calling my function on n equals 9 and my function on n equals 8. And within that n equals 9 call, it's also going to make an n equals 8 call in this n minus 1 mental model again. So definitely making a lot of repeat calls that could be cleaned up. So I think a good way to maybe save those calls is to do this and save the results in an array and kind of build upwards towards the final end that we want.
Sounds good.
All right, so I can start off my array with my base case. So and then I'll do some magic in the middle and turn my array at n very end. So if n is 0, that'll go to 0. If n is 1, that'll get us 1. Okay, great. I'm going to do a little bit of magic in the middle. So I'm going to loop until n. Actually, I'm going to start from I equals 2. My let statement there. All right, and each using that recursive statement again, I know that at this item, Fibonacci, the answer for this sequence is going to be the last answer and the one before that as well. Great, so I think I have something a lot more efficient than what I initially had. I don't know why I called it 2, both one. Yeah, I think I have something a lot more efficient than what I initially had. It's still using that recursive definition, of course, in the base case. But yeah, upon doing this one, I start to realize that we actually don't really need an array at all. Like if I'm using If I'm using like n equals 10, for example, ultimately that entire array, after a certain point, we really don't need that information anymore. And so it's kind of just a waste to store it. So an idea I have is to use some constants, a constant number of variables to keep running values of what this I minus 1 and I minus 2 solutions are, and try to do this question without any extra space.
I see. That's cool.
So I'll jump right into that. So same old, keep the function down. All right, so I'm gonna use 1 to represent whatever is in the solution at n minus 1. Start with 0, since let's assume that we have n minus n is equal to at least 2 for now. And then and I'm just gonna leave it 0 as placeholder just to make my life a little easier. I'm just gonna copy those down. All right, so we're gonna actually do this loop again. So I'm gonna grab that loop. And then ultimately I want to return whatever is in my solution. So my solution is going to be the last 2 results. And then I need to actually shift my last 2 results upward in preparation for calculating the next I solution for our Fibonacci sequence. So I'm going to want 2 to equal solution and then 1 to equal the previous 2. So I'm actually going to hold on to 2 first. And then 2 is equal to what solution currently is. And then 1 is what 2 currently is. And then return the solution. So, okay, let me just think about this one more time. So we start with 1 is 0, 2 is 1. Yep, that's our base case. Okay, and then at I equals 2, we're taking the, oh, this is actually, mentally this is backwards. That's a very small thing though. I think it would still work out. Yeah, so at n equals 2, we're going to take f of 1 plus f of 0, which is going to get us 1, and then soul is going to become 1, and then 2 is going to become 1, and then 1 is also going to become 1, and then on f of 3, we're going to have, 1 plus 1, that's 2. Great. So I think this works.
Okay, cool. Actually, I guess because we have like a little bit of time, I think we're almost near the end of the slides. Maybe we could run through an example. Sure, how we could do that. Try that.
Yeah, like just run the code.
No, not run the code. I mean,
Okay.
like walk through an example. Yeah, I mean, you can run the code if you want to.
Oh, walk through an example. Yeah, I see.
Yeah.
Yeah. So let's. Oh boy, Fibonacci number on the spot. Okay, 0, 1, 1, 2, 3, 5, 8. Okay, that's good enough for now. So let's go with 4, 5, n equals 5. Okay, so starting at starting at n equals 2, because we've covered the n equals 0 in one case. At n equals 2, we want the solution to be 1. So we're looking at 1 and 2. We're going to add them up together. This becomes kind of irrelevant for the returning solution right away. And then, yeah, we'd be getting 1. So if we go to n equals 3, we're going to have, I'll just keep this. Two is going to be 1. 1 is also going to be 1. And we're at equals 3 right now. I'm trying to keep the code on the screen and most of the comments on the screen. Yeah, so then solution at n equals 3 is going to be 1 plus 1, which is 2. And then 2 is going to move up to 2, and 1's going to move up to 1. And then we're going to move on to n equals 4. I should also be referring what the goal is here. We're at 3 right now, I believe. Okay, so then we're gonna look at, oh, sorry, no, so we'll have to calculate at this point. So we're gonna look at 2 and 1. 2 plus 1 is 3. And then we're gonna move 2 up to 3, and then 1 is gonna become what 2 used to be, which is 2. And then we're gonna move on to the next n. So we're looking at 3 plus 2, which is 5. And then 2 is gonna move up to 5. 1 is gonna move up to 3, and then move on again. 3 plus 5 is 8, and then so on and so forth.
Yeah, that looks good to me.
Awesome.
Yeah, so like a bunch of things went really well with this interview. So starting with the brute force approach first, as I explained, like brute force approach first, as I explained before, is a great idea. So then you can like get some code out or get your thoughts out, and then come up with the DP intuition as a way to optimize the brute force way. So I think like Kristy did a great job with that. Also, it was great how Kristy changed her solution to be built up from the base cases for her DP approach instead of just like using cache of sorts for her original function, like recursive approach. Also, not on the slide, but I think that because we ran through an example, the way Kristy like wrote out each of the variables and then walked through how each of them changed step by step throughout the code was great, because that way you can run through your code and see if there's any issues and like find what those issues are and fix them with your interviewer. Like when you run through an example and you find a mistake, then you can fix it. And like you're not going to be penalized for that, and like you shouldn't try to hide those, because like your interviewer is going to be able to like tell that like, oh, like that was a mistake, like they know, so there's no point trying to hide. So running through examples to find like bugs in your code is like a great thing to do, even if it actually ends up resulting in bugs. Okay, so this is the final like technical content slide. So sorting and searching, as a lot of you have probably seen, binary search is an extremely common algorithm used for these problems. And like Kristy mentioned it before, but if you're given a sorted array or even like a not sorted structure, sorting it to use binary search is often a very typical solution. Quicksort and quick select use similar sort of ideas where they have pivots, you move stuff around the pivots, and they're very common in lots of problems. And merge sort, I think I haven't really encountered using it in an interview myself. However, like the concepts behind it, like the divide and conquer idea, is widely applicable, where you split a problem up into 2 smaller subproblems and those ones into smaller subproblems and so on. So understanding how it works could help you solve those sorts of problems. For each of them, like you should understand how to implement them, what their complexities are, runtime and space, and you should practice using them. So one quick note here, I forgot to mention earlier about binary search. Binary search, people get tripped up a lot by like off by 1 errors and like less than versus less than or equal to or not. So this is one of the few things I'd recommend. In addition to understanding the intuition, like you should actually try coding this out and making sure you could get like binary search like working, because I think those off by 1 errors and stuff are quite typical for this one. Okay, so finally for practice, this is like the last thing we talk about for a reason, because as much as you can watch like 100 of these talks or read Cracking the Coding interview or whatever, yeah, we'll talk about resources later. It doesn't matter how much theory you know unless you like practice using this theory in problems. So like the best way to get good at interviews is to practice. So now let's talk about how you could practice.
Yeah, so for some resources.
Yeah.
Sorry, Bimesh, I don't remember. Did you want to take this slide or?
Sure, I'll take it. So like we'll start off with like practicing problems. So LeetCode, HackerRank, you guys probably know these websites. You can practice doing problems, learn about these algorithms, and make sure you understand the concepts. And like here it says easy and medium problems are what you need for 90% of interviews, and that's generally the case. I think like in like lots of jobs, especially some of like the really competitive ones, it's quite possible that you see problems that are hard. However, I think like what's great about having an interviewer is that even if you might not be able to solve this problem yourself on LeetCode, if you are good at explaining your thought process and like saying what you're thinking out loud, then the interviewer could provide you with hints and nudge you in the right direction. So then you can transform this like mystical LeetCode hard into like a much easier problem solving process. Okay, daily coding problem, you sign up, you get an email with a different problem every day. Like my friends and I, like in first year, signed up for this and like looked at the questions every day. It was like a fun reminder to like think about interview problems. Okay, there are some books. A bunch of people really recommend these. I personally didn't take advantage of these, but it's been a useful resource for a lot of people. Okay, Cramp I actually have a personal experience with. So originally in like my earlier internships, I like was pretty decent at doing LeetCode problems and like solving problems, like just random problems myself. However, I noticed when I was practicing with my friends that I had a lot of trouble explaining my thoughts out loud and like communicating what's going on in my mind. And that made it so even though I could solve problems, I still wasn't doing very well in interviews. And like signing up for Premp and doing like a bunch of mock interviews back to back with random people really helped improve those skills for me. And it was quite a great experience for me, so I'd quite recommend it for anyone. Okay, and finally, similarly to Prep, just doing mock interviews with friends in upper years is like a really good way to get a much more reflective experience of a real interview compared to something like LeetCode or doing daily coding. So yeah, with that, I think it's QA time. Yeah.
Awesome. Thank you so much, guys. That was a great presentation. And yeah, I'm just going to get started by reading some of the questions on the Slido. So our first question is, does space complexity include the space taken up by function calls on the stack, e.g. from recursive calls?
Yeah, so typically when we talk about space complexity, you would talk about the space on the stack because that is like space that's taken up. So yeah.
Whoops, probably should have mentioned that in the tree question. My bad. Good question.
Awesome. Okay. Next, we got, is the difficulty of these questions representative of what you usually see during technical interviews? Does it vary a lot between the big companies?
I think I usually get more challenging questions. We picked some rather common, simpler ones, so for the interest of time. But yeah, I think I feel like I've run into an interview where I have like maybe one or two of these easier questions as well. Yeah, what about you, Bimesh?
Yeah, I think similarly. And I think like even within particular companies, like different interviewers give different difficulties of questions. Like, yeah, so yeah, but I think definitely more difficult than the problems we did here. I think these were like easy by purpose.
Great. Okay, and next up is, how many examples would you recommend running through in a real interview?
I think quality, sorry.
No, you go ahead.
Yeah, I think quality over quantity. So like one to, run over the like majority of cases, but definitely like going for whatever edge cases might be present is a lot more important than like hammering home a bunch of examples for the sake of hammering home examples.
Great. Okay. Do interviewers usually make you compile and run your code?
Depends on the company.
What would you do if you're drawing a blank or get stuck during an interview?
I think for me, like the best thing is explaining why I'm stuck and what I'm thinking about in my head. And like in basically every single case I've managed to do that, an interviewer would like nudge me until I could get to like the right answer. And even if like there was no way I was going to solve that problem, I've like still had successful interviews just by them nudging me to solve it. So
Great. Next up, for the balance brackets question, would it be okay to implement a while loop solution that does not use the intended stack solution?
yeah, like for like this problem, since we were trying to show off stacks, we use stacks, but like for any problem, like a variety of solutions would work. And as long as you talk about like the space and time complexity and like why you're picking the particular solution, like there could be lots of right answers. Yeah.
Okay, next question. Would you say some data structures slash algorithms are more important than others? What should I prioritize studying?
I don't want to be a bad influence, but I will say I got away with not knowing much about heaps for a very long time. Doing a lot of graph problems I found really important because like the nuance between when you should use DFS and DFS is like an intuition you have to build just out of practice, really. Yeah, Bimesh, do you want to add anything?
Um, I think like we tried to cover things that are like relatively typical. Um, so like I think this presentation's good guide, but Leak Code I think has like good sections on like common structures and like the number of like problems like for each of the things. So I think that might be a good way to go about too. But I think if you typically understand the stuff taught in like CS classes, like 240, 341, stuff like that, you should be fine.
I think HackerRank also has an interview prep, like website, web app thing, that kind of takes a selection of a few of their different questions, as well, with kind of the same thing in mind of like presenting what's most commonly asked. It also provides warm-ups, which I find really helpful to kind of ease off the stress if it's the day of a big interview. So I recommend checking that out as well.
How do you look for leak code questions to do? There's way too many, kind of adding on to that.
I think I try to find so like some ways like one like if I was just trying to practice interviews in general, I might just like pick a difficulty and just pick like a random question and try to look for something that has like high upvotes. So it's like something that's like a good question and not just like doesn't have like some hacky solution. Um, Also, I typically, if I was trying to practice a particular topic, look for questions in that topic. I think like LeetCode's good at that. Upvotes, topics, those are kind of the filters.
Yeah, I often also practice by topic.
What ratio of learning slash practicing on your own to practicing interviewing do you think is most effective? I can re-say the question if you need me to as well.
I think I'm good. I think I spend like in terms of hours I've spent practicing like interviewing with other people versus hours I spent on lead code. I think I've spent a lot more hours on lead code. That being said, like just because the proportions are different doesn't make practicing with actual people any less valuable. I think that is really important. Yeah. Dimash, did you want to add anything?
Yeah, I think like it's like I struggle to answer this because like personally I just did a bunch of leak code and like got decent at leak code, but then it was just like I was really bad at the actual like explaining interview parts. So it's kind of like based on what you're good at and you're weak at, you should decide what to prioritize. Like that's kind of what I feel.
Really well said. Awesome. Why is Bimesh so cool? Also, Kristy, why are you both so cool? You're great. For a junior role, what can we expect? Will they ask about time and space complexity?
Very much possible. Yeah, I've been asked before for like some of the earlier co-ops I've had. I have also noticed some in like the interviews I had for my earlier co-ops, there's often some questions that are more role specific as well. So like if you're front end, they might ask you to implement something really quickly in front end. Yeah, Bimesh, did you have anything you want to add?
I guess like the interviews we talked about are kind of like the typical interviews you see at like more like general software roles, but like smaller companies and I guess also specific roles talk about more specific stuff, I guess. I remember having like interviews about like Java trivia or just like other really random things that aren't like what we talked about. So maybe looking online to like searching up like company name, internship interview questions or something like might be able to give you some hints.
How do you prove that your solution is correct, apart from verifying with test cases?
Yeah, I think try to make a convincing case uh, for graphs and for trees. What I find helpful is like I kind of touched on this a little bit in the tree similarity problem we did. But if you can like make very rigorous statements about your base case and all the possible edge cases or like all the possible situations that your trees or graphs are in, and like really define that recursively, that's usually proof enough. So that's for like recursive situations.
I think adding on to that, like in an interview sense, you can also kind of like, okay, this sounds really strange, but like proof by vibes, like ask your interviewer like, hey, like, what do you think about this? And like talk through examples. And I think usually they'll like point out things to you like,
Do a vibe check.
yeah, vibe check.
For someone who struggled to find interviews in their first co-op, what would you say are the best ways to actually land interviews?
Yeah, kind of going back to a really quick slide we did at the beginning about stuff outside the interview. I think my resume carried me a bit in first year. So doing those side projects and being able to speak of like the both the technical experience you've had as well as the potential impact of the projects you've worked on if they've had users or stuff like that. Bimesh, did you want to add on to that?
Yeah, I think like side projects and like other experience and like clubs and stuff are definitely useful, but like for the people who are like struggling in early years, like it gets easier. Like even if you don't do anything, it will get easier, but if you do stuff, it'll get easier like faster. Like just like getting older is a good strategy to get more interviews, like high key. Yeah.
How many hours do you recommend us spend per week on prepping for data structures and algorithms?
I didn't exactly count my hours when I was in like when I get into like hiring cycles. I generally go for like I want to say like 2 or 3 questions a night, but I'm usually like not as diligent as I'd like to be, so usually ends up being like 5 out of 7 days a week. For 3 questions, sometimes on weekends do a little more. Yeah, I don't. Beamish, do you have a hour recommendation?
Um, I don't have an hour recommendation, but I think like I practiced a lot less intensely than that. I think I'd like to like for successful interview seasons, I generally like try to I guess like start earlier and just do like one problem every like couple or like a week or something, and like maybe as you get closer, like do some more problems. But I usually try not to like do too many because I just get bored.
Awesome. How do you study for design questions? An example here is design a URL shortener or design a data structure.
Yeah, that's a great question. I have exclusively studied and practiced design questions with friends to like talk about them out loud. The thing with a lot of system design interviews is you don't really do much coding. You're just like talking about it. And so like, you could just talk to your wall, but you'll get the best feedback talking with other people. So this is definitely one of those categories of questions where like the proportion of me doing it on my own and doing it with people is a lot different from other lead code questions.
To add to that, there's like a really great GitHub repo with like a bunch of systems design questions. I don't know if anyone has that, if they could like post it in the chat. It's like called like system design primer or something. You might even be able to Google for it. But there's like a bunch of examples of system design questions and like the sort of trade-offs and stuff you have to consider. But personally, I want to say like maybe had like one system design interview, like ever. Like it was very rare for internships, at least from my experience.
Yeah, same with me.
Awesome. Has anyone done front-end interviews? If so, would we get similar questions to these?
I have done front-end interviews. Let me think back for a second. There was one front-end interview I did that required me to do some like practical front-end stuff, so like implement this thing in React. But it did have a bit of an algorithmic element to it. And then there's another company that I did front-end interviews for more recently. This was like last term. And it was, how do I describe this? JavaScript, and still had some algorithmic stuff to it, but it leveraged a lot of like JavaScript specific things. So I kind of had to know like what was going on with prototypes and like constant stuff, and they really looked for like good JavaScript formatting as well. That's been my front end experience. Yeah.
One quick thing about resources. Someone asked, what was the website you said? Can you please put it in chat? So I think this was adding on to the resources you guys mentioned before, where Kristy said a site to warm up, maybe, if you don't mind repeating some of the resources you've used.
Yeah, here, I can even move my screen back. The site for warming up is HackerRank. They have an interview preparation website as well. If you just look up like HackerReg interview kit. That's where I like to do my warm-ups and like kind of get into the mindset for interview season.
Thank you. After you do your technical interview, is it a good idea to send the person an email to thank them or connect with them on LinkedIn?
Can't say I've ever sent them an email afterwards. I think I might have connected with them on LinkedIn once or twice. I'm not the most active on LinkedIn though, so I don't think I have the best answer.
I think like I read a bunch of stuff about this like back in first year, and I tried to like do these sorts of things like send emails and like LinkedIn connections and stuff, but I personally didn't like experience any additional success because of it. But like I guess other people online have, so I can't really comment on whether it's a good idea or not.
For a junior role, if they say I can use any language I want and I use Python, will they restrict me from using any built-in libraries?
I think usually, unless the like tool you're using or like the structure you're using like solves the entire question for you, interviewers like are like love that you like know that this thing exists and you could like leverage it to solve a problem. Like for example, if you're like building a hash map and you just use like the map, like you can't do that. But like otherwise, I don't think I've ever been like I don't think anyone's ever told me like, oh, you can't use like this queue or this like other thing from a structure or from a like language.
How specific should you be about frameworks used in your resume? For example, should you mention React specifically or just general methods used to get a solution?
Yeah, I've mentioned specific languages. It's going to depend on what the company is looking for. Some companies like use maybe a bit of an unconventional language, and they're totally cool with like their developers not knowing languages before. I've had interviews where like after the lead code aspect, they call it like, oh, it's super cool that you used like this specific thing. We're thinking of using this for our end-to-end tests, or like, oh, it's great that you have experience in this. We actually use that in our stack as well. So it's definitely been variable across interviews for me. I think at the end of the day, though, I still err on the side of keeping the specific things I'm familiar with on my resume.
Should I expect leak code questions in a 20-minute QA interview?
I'm not sure. I've never done a QA interview. 20 minutes is fairly short, though, for a leak code, I think.
I remember having like sort of like team matching sort of calls that were like really short, but like people still like the manager or whatever still like asked like a sort of technical-ish question. Um, so I don't know. I wasn't expecting that, but I think like typically like no. Also, if it's with like a recruiter, like no.
Any tips on choosing a side project?
I always tell people to pick what they're interested in learning. So if you want to get into front end stuff, do a side project related to front end. Want to do back end stuff, do something there. I had a mentee who had done a lot of side projects that I thought were interesting, which was he did clones of different popular websites. And so it also helps you kind of get into that systems design thinking as well. Ask yourself, like, how does Twitter really implement this? How does Airbnb actually implement this? And you can go as far into the back end as you want for those kinds of things, or as far into the front end as you want. Yeah, Bimesh, do you have any suggestions?
Yeah, like adding on to the of interest to you thing, I think like a thing that I struggled with is like continuing to work on my side project so it like ends up becoming something like that's like worth talking about. And I think like picking something you like are actually interested in working on is like a really great way to like help motivate you to work on.
I also don't think side projects always have to be something you do alone. I see a lot of people doing that, and I definitely did that a lot in first year. But there's plenty of clubs that need technical tools that has a purpose, has users, gets you in a team environment to work on it and get motivated on it. There's also things like Coffee and Code that helps match you up with people who are looking to do side projects. So yeah, lots of ways to also like find motivation to stay on top of it.
How valuable are references for jobs?
I've never been asked for a reference.
Mhm.
There you go. Do we need to come up with our own unique side project ideas? Does following a guide, step by step, switching minor steps, discount our project on the resume?
I think I've seen like successful like resume like side projects listed on resumes that were like basically like following a guide. I think like you follow the guide and build something interesting, like we'll talk about it, I guess. Like I don't see what's wrong with that. But I guess like in terms of like actually learning stuff, like if you just like copy and paste the code, like I don't know. If they like ask you like details about things like in projects, which like people do in like many interviews, you might like you should like make sure you know what you're talking about, I guess.
You can always spin it a little bit as well to make it a little more personal and unique to yourself. Like if you're making an Airbnb clone, maybe you can swap out some basic stuff, and instead of making it a like um, rental marketplace, make it a marketplace for like, I don't know, fruits or like something you have a hobby of.
How do you deal with nerves before a really important interview?
I love to do warm-ups before interviews. I didn't start doing this until last year, and it has really improved my nerves before doing an interview. So what I mean by warm-up is a super simple question on Leet Code, like easy, a ridiculous number of thumbs up, and it just like gets your fingers into the typing mood, gets you into the like Leet Code zone a little bit. Um, and it's not too hard, so it builds up some confidence as well, since you can usually get it on the first run. That helps me a lot with my nerves. I always do that before a big interview.
I think like two things. One, like I typically like listen to whatever music I'm into at the time to like calm down. But also, I think just like having more interviews, even if they're like about companies you might not be super interested in, like really get you into like the interview like mood. And if you like do a bunch of interviews, like even if you don't care about the company, for when it comes time to the time it's like the interview you care about, you'll be like a lot more like chill, at least from my experience.
Yeah, another thing, if you have this luxury, like scheduling all your interviews to be within like similar days, it might make your academic life suffer a bit, but I much prefer to get all my interviews over with within like a short time period. And it also helps me keep in the mood, keep in the mindset of interviewing and everything as well.
Definitely. Is having a LinkedIn and/or personal website important? How impactful is it in getting internships?
Personal website, I've seen no change in my professional life ever since I stopped posting it because it had all the exact same information as my resume and stuff. I have been like, I have had cold reach outs from recruiters on LinkedIn before, but I did try like pretty hard in first year to like stay in touch with recruiters and stuff on LinkedIn, and it was a fairly fruitless endeavor. But it's nice to get a cold reach out every once in a while and think about what they're offering, or like what they want you to apply for and stuff.
What are some non-technical interview questions that interviews ask?
Tell me about project listed on your resume, and they'll want you to like kind of go in depth in it, mention the technologies, mention the challenges. What's a difficult what's a difficult technical challenge you worked on in the past? Usually I'll mention a previous internship project. Um, yeah, Beamish, can you think of anything?
Mm, I think like to be honest, in like the last few internship cycles, I got like basically no like questions like that. But I think earlier, like specific projects, um, and like I've even got like just like tell me about yourself, like typical like, questions. So like having answers to that might be useful. I don't know.
Do you find, oh,
No, nothing. Go ahead.
oh, good. Do you find there's more success in getting jobs on Waterloo Works or externally?
At least for me, I found Waterloo Works to be like a lot like higher hit rate and more successful. Like I'd apply to like the same company outside of Waterloo Works and like not hear anything back, but then like get interviewed at Waterloo Works. So I've always thought Waterloo Works is great.
I've had a bit of a reverse experience. I'm on my last co-op right now, and like 5 out of my 6 co-ops were all external jobs. I've been pretty lucky with external applications. And like in my view, sending a resume off to one more website or one more company isn't a ton of effort. So I still go for it anyways. That being said, I would say like the rate at which I get, like the percentage of applications that lead to interviews on Waterloo Works is higher than external. But like external is definitely still a viable option.
For sure. And actually adding one more thing to that, I think like there are a bunch of jobs that like come out externally a lot earlier than Waterloo Works, like especially for the summer. Like these companies are like done hiring in October. And like for people who don't specifically come to Waterloo, if you only start looking at them in like January, it's gonna be too late. So yeah.
Yeah, big plus one to that. Especially American companies because they're working with the American school system. And like American kids don't have the weird Waterloo schedule we have. Yeah, they start hiring in October.
What advice would you give to someone in grade 12 right now? Is there anything to do over the summer?
Enjoy your summer. The last one you've got. I don't know. Bimesh?
Yeah, I don't know either. I think enjoy your summer is like really good advice because like I guess if it wasn't for COVID, like a lot of us would have basically never gone home again, except like for 2 weeks in between terms. So, yeah. But like for technical stuff, I think like you can definitely like read books like Cracking the Coding Interview or do Lead Code. Like a lot of the stuff you learn in grade 12 CS is like the foundation for a lot of these things. It's not like that much more complicated. Yeah.
Oh yeah, if you're in high school, Echo and CCC and like those
Yeah.
like competitive programming competitions are like really aligned with what you're gonna see in interviews later. So if you enjoyed that stuff, maybe try some of those practice questions for fun. They're all available online. And a little piece of non-technical advice as well. I highly encourage like doing something that takes a few months of work or so on and so forth that you normally would not be able to do in a college setting. So for me, that was finishing up my piano credentials. I like haven't been able to play piano ever since I got to college, so I really appreciated that I spent my summer on that rather than on side projects and stuff.
Not a question, but as a beginner, I really appreciate how Bimesh and Kristy wrote the steps to their solutions first and explained everything step by step. Adding on to that, you guys were fantastic. Thank you so much for the work you guys put into this presentation and how you explained everything. It was super helpful, I'm sure, to everyone watching. If anyone has any burning questions, please add them to the Q&A now. But otherwise, I think we'll be wrapping up this session. To answer one last question, this will be recorded and it will be available in the VODs section of this Twitch, and it'll probably be posted on YouTube as well afterwards. And yeah, thank you so much to you guys for creating an amazing presentation. And if you need to get in contact with SE Soc or CS Club afterwards, the contact information is available on the stream. And yeah, we really appreciate you guys coming out and to the session.
Cool.